So in this video, we're going to look at how to convert from rectangular coordinates to polar coordinates. So first, there's a set of equations that help us navigate back and forth between rectangular and polar coordinates. So let's look at where those equations come from. So if you think about, if you go to plot a point, so say the point is here, we've gone out some distance x on the x-axis, and we've gone up some distance y, which means that the coordinates, the rectangular coordinates of this point is x comma y. And so instead of thinking of it x comma y, we want to think of it as we went some angle theta and we had some radius r. So if you look, I have a right triangle here. So the first equation is that it has to satisfy Pythagorean theorem. So x squared plus y squared has to be equal to r squared. And then secondly, if we think about it, x over r, so the adjacent over the hypotenuse, that's going to be equal to the cosine of theta. So this tells us that x is equal to r cosine theta. And then y over r has to be equal to the sine of theta because it's the opposite over the hypotenuse. And so that tells us that y is equal to r sine theta. And we could also say that the tangent of theta is equal to y over x. So the x equals r cosine theta, y equals r sine theta, the tangent theta equals y over x, and x squared plus y squared equals r squared are the equations we're going to use. So, for example, convert the point or the points to polar coordinates. Okay, so the first one here is the point 2 comma minus 2. So if we think about going here, 2 comma minus 2, so we're going out 2, and then we're going down 2. So this here is 2, this here is minus 2. We can draw this hypotenuse here, and so we can find the hypotenuse, that's going to be r. So remember, x squared plus y squared is going to be equal to r squared. So 2 squared plus negative 2 squared is going to be equal to r squared. So that's going to be 4 plus 4. So 8 is going to be equal to r squared, and r is going to be equal to plus or minus the square root of 8. So we're going to take it to be the positive. So square root of 8 is equal to r. And then the other thing to remember is, so this is square root of 8. My triangle here happens to be, since the two legs are the same, one's just negative, that's just saying the direction it's going, but the values, so they're both of length 2, what that means is this is a 45, 45, 90 triangle. And so if that pink angle there is 45, we're interested in the angle that rotates this way, so that's going to be 360 degrees minus the 45 degrees, which is going to be 315 degrees. So if I go to write r comma theta, in this case, that's going to be square root of 8 comma 315 degrees. So that's that point in polar coordinates. So let's try another one. B, minus 2 root 3 comma minus 2. So again, if I go out minus 2 root 3, say that's somewhere here, minus 2 root 3, and we're going down to minus 2. So again, I can use x squared plus y squared equals r squared. So x is going to be, so we have minus 2 root 3 squared plus minus 2 squared equals r squared. So this is going to be 4 times 3 plus 4 equals r squared. So 12 plus 4 is going to be 16. So r is going to be plus or minus the square root of 16, or r would be plus or minus 4. Again, because we're dealing with the hypotenuse here, we're going to make it the positive 4. And then if you look at it, remember we had the 30, 60, 90 triangle. And in the 30, 60, 90 triangle, we have the relationship is the following. So let's say this is the 60 degrees, this is the 30 degrees. So the side across from 30 is x. The side across from 60 is x root 3, and the hypotenuse is 2x. So if you look at what we have over here, I have a thing that's minus 2 root 3. And so the negatives are just telling us that we're going to the left and we're going down. So you can ignore the negatives. So we have here 2 root 3, 2. So this side is my x side. This is my x root 3 side. So that means across from the x has to be the 30 degrees. So then the angle we're looking for starts at 0 and wraps all the way around. So it's going to be 180 degrees plus the 30 degrees. And so in this case, that means we are going to have 210 degrees. So our polar coordinate is going to be 4, 210 degrees. And you could write it in radians as well, right? You can convert 210 degrees to radians if the problem asked you to write the answer in radians.